2017, paper 1, question 5, differentiation. So here we're given a function and we're asked to show that x equals minus 3 as a root and then also find the other two roots. So when we want to show that something is a root, what we want to do is show that it satisfies the equation. So we can do that one of two ways. We can sub in for x is equal to minus 3 into the function. So in other words, wherever there's an x, we're going to put minus 3, making sure that it's in brackets. And basically we're using our factor theorem. So what we want to do is show that this should equal 0. So again, we have to be careful when multiplying out a negative number here. So we have minus 3 cubed. So when we have a negative number to an odd power, the answer is always going to be negative. So if you don't get a negative number when you're putting it into your calculator, you know you've done something wrong. So when we multiply 2 by minus 3 cubed, we end up with minus 54. And then we have 5 times minus 3 squared. So here we have a negative number to an even power. So that should give us a positive number. So again, if you don't get a positive number when you multiply 5 by minus 3 squared on your calculator, again, you know you've done something wrong. So again, always making sure you're using brackets on your calculators correctly. So then we have minus 4 by minus 3, which is of course plus 12, and then minus 3. So when we add minus 54 and 45 and 12 and minus 3, we end up with 0. So therefore what that tells us is that when we sub minus 3 into our function, our output is 0. So that tells us that x equals minus 3 is a root of the function f of x. And therefore that also tells us then that x plus 3, so in other words, if I bring the minus 3 to the left-hand side there, I get x plus 3. And then that means that if x equals minus 3 is a root, x plus 3 is a factor. And that's going to help us find the other two roots, because when we know it's a factor, that means that it should divide in evenly with no remainder. And that's also another way of showing that x equals minus 3 is a root. So I'm going to then take my x plus 3. I'm going to divide that into the function 2x cubed plus 5x squared minus 4x minus 3. So we have x into 2x cubed, and that goes 2x squared times. And I'm going to take that and I'm going to multiply it back out by the x plus 3. So that gives me 2x squared by x, which is 2x cubed, and 2x squared by 3, which is 6x squared. I then need to change the signs, so it's always important to use a different colour pen when you're changing the signs there. So if you go back to check your work, you know what you've done. So that gives me 5x squared minus 6x squared, which is minus x squared. And then we start the process all over again. So x into minus x squared goes minus x times. We're going to take our minus x, we multiply it back out by the x plus 3. And we also have to bring down this minus 4x as well. So we have minus x times x is minus x squared, and minus x times 3 is minus 3x. And again, we change our signs. So that gives me minus 4x plus 3x is minus x. Bring down our minus 3. And we know we're nearly at the end here because there's nothing left to bring down. And then we take the x and divide it into our minus x, which gives us minus 1. And then last step, multiply our minus 1 back out by x plus 3. And that gives us minus x minus 3. And again, change your signs, and that leaves us with 0. So again, the fact that we have 0 here tells us there's no remainder, which shows us again that x plus 3 is a factor, and then hence x equals minus 3 is a root. So now what we want to do is factorize our quadratic to find the other two roots. So in other words, we're going to let the second factor, 2x squared minus x minus 1 equals 0, and we're going to solve. So we have 2 times minus 1 there is minus 2. What multiplies to give us minus 2 and adds to give us the middle term there, minus x, must be minus 2 and plus 1. So we have 2x squared minus 2x plus x minus 1 equals 0. And we want to take out our highest common factor between the first two and the second two. So 2x is common, leaving us with x minus 1. 1 is common, leaving us with x minus 1. And again, we want to take out our highest common factor. So these two brackets should always be the same. So I can factorize. So if you have a sign wrong, your brackets won't be the same. So then we end up with two factors, x minus 1. So if they both multiply to give us 0, that means that x minus 1 must equal 0. In other words, x equals 1. Or 2x plus 1 equals 0, meaning that x is equal to minus a half. And therefore that gives us our other two roots. In other words, the three roots of f of x, so our three roots of f of x are x equals minus 3, x equals 1, and x equals minus a half. So again, always checking, are you looking for the factors or the roots in these questions? In which case, we would write x equals versus our factors. So it was 15 marks for this question. So we had 0, 5, 10, or 15 were the breakdown for the marks. So for B, we were asked to find the local max and the local minimum point of the function. So the fact that it's looking for the coordinates means we have to find the x and the y coordinate, not just the x value. So it's always important to check that. And we also have to distinguish which is the max and which is the min, which means we'll have to use our second derivative test. So our function was y is equal to 2x cubed plus 5x squared minus 4x minus 3. So to find our max and our min, we're going to find our first derivative, let it equal to 0 and solve. So if we're finding the first derivative, we're using our general rule here. And again, your general rule can be found on page 25 in your maths tables so that you can remind yourself just in case you can't remember how to differentiate. So it should, of course, be 2x cubed is going to be bring down our power and take 1 away from our power. So 3 times 2 is 6. Taking 1 away from the power reduces 3 to 2. 5x squared differentiated. Well, if I bring down the power, we're going to have 5 times 2, which is 10x. And take 1 away from the power, it just leaves us with x to the power of 1, or just x. And then if we have minus 4x differentiated, well, if I bring down the power, I have 1 times minus 4. And taking 1 away from the power leaves us with x to the power of 0. And of course, x to the power of 0 is just 1. And then if I differentiate a constant, it always goes to 0. So in other words, my first derivative is 6x squared plus 10x minus 4. So to find our max min, we're going to let dy dx equal 0, and we're going to solve. So we have 6x squared plus 10x minus 4 is equal to 0. I can only simplify after I have let that equal to 0. If it's not equal to 0, you cannot simplify your dy dx, okay? So I'm going to divide across by 2 here, which is 3x squared plus 5x minus 2 equals 0. So what multiplies to give us minus 6 and adds to give us 5? Well, it must be minus 3 and minus 2. Or sorry, it must be 6 and minus 1, I should say. So that should give me 3x squared plus 6x minus x minus 2 equals 0. So what multiplies, take out the highest common factor between the first two terms and the second two terms. So we have 3x is common, leaving us with x plus 2. Minus 1 is common, leaving us with x plus 2. So again, we can see our two brackets are the same. And again, taking out the highest common factor a second time. And if I take out the highest common factor, x plus 2, I'm left with 3x minus 1 is equal to 0. So we'll let both of these factors equal to 0. And that gives me x equals minus 2, or 3x minus 1 equals 0, so x is equal to a third. So now we have two values for x, and we need to find the corresponding y values, and of course test which is the max and which is the min. So we're going to test which is the max and min first, and then we'll find the corresponding y values. So we'll do our second derivative test. So if we go back up here, I'm just going to start. We have dy dx was equal to 6x squared plus 10x minus 4. So if I differentiate that, that gives me 12x plus 10. And now what I want to do is sub in these two x values and see which is going to give me a positive value for my second derivative and which will give me a negative value for my second derivative. So we're going to test x equals minus 2. So when I sub that into my second derivative, what does it give me? Well, I have 12 times minus 2 plus 10. So that's minus 24 plus 10, which equals minus 14. And of course, minus 14 means that the second derivative is negative. In other words, it's less than 0. So therefore, that means that x equals minus 2 is a maximum. That gives me my local max. And if I sub in x equals minus 2 into y, well, we end up with 2 times minus 2 cubed plus 5 times minus 2 squared minus 4 times minus 2 minus 3, which is 9. And therefore the local max is minus 2, 9. So we would, of course, expect that our local min is going to be when x is equal to a third, but we still have to show that. So again, we have our second derivative. Let me just write that down again. The second derivative was equal to 12x plus 10. So when I test x equals a third, well, we have 12 times a third, which is 4, plus 10, which gives me plus 14. So in other words, my second derivative when x is equal to a third is positive, and in other words greater than 0. So therefore it's a local min when x equals a third. So of course then y is equal to 2 times a third cubed plus 5 times a third squared minus 4 times a third minus 3, which gives me y is equal to minus 100 over 27. So in other words, the local min is a third minus 100 over 27. So now we have our local max and we have our local min, and there was 5 marks going for that. So it was 0, 3, 4, and 5. And of course, from year to year, that it'll vary how much these questions are worth depending on marking scheme. So what might be 5 marks one year could actually be worth 15 or 10 marks a previous year. So for part C, we were given the function plus some constant that gives only one real root. So if we look at the graph f of x itself, we see that it's a cubic function, and we've worked out what the max was and what the min was. So here we had our local max, which was minus 2, 9. And we had the local min, which was a third minus 100 over 27. So obviously as decimals that would be 0.33 and minus 3.7. So if we want to find where there's only one real root, basically that means that the graph will only touch the x-axis once. So there's two things that can happen. The graph can shift up the y-axis, or it can shift down the y-axis, so that the graph will only touch the x-axis once. So basically that means that the max will touch the x-axis once, or the min will touch the x-axis once. Therefore that means it's shifting up or down the y-axis. So what we end up with is a graph like this, where we can see the blue is our original graph, and the red has basically moved the graph in an upward direction. And it's moved up so that the min now sits on the x-axis. So what's actually happened is that the graph has shifted in an upward direction by adding on our 100 over 27. So in other words, we've added on a value a to our function such that our min is now sitting on the x-axis. Or what we can have is that, again, the blue graph is our original. We shift the graph in a downward direction down the y-axis, and we're shifting it down by the y value. So the y value being 9 units. So in other words, I've moved it down 9 units. So in a downward direction would be minus 9. So we've subtracted 9 from all of our y coordinates, or we've added 127 to all of our y coordinates. So what that basically means is that if it only has it 1, we shift it up by at least, so we shifted it up the y-axis by at least 100 over 27 units, or down the y-axis by at least 9 units. So what that then tells me is that a has to be greater than 100 over 27, or a has to be less than minus 9. And there was 5 marks going for that, and it was broken down into 0, 3 or 5, so getting one of them right or getting both of them right. So a nice little addition onto that question there, which really is applying your functions knowledge, so your transformation, shifting it up or shifting it down.